In today's lesson, we are going to talk about acceleration and deceleration. Definition of acceleration is any change in speed or any change in direction. That last part is super important. If I'm going 44 miles per hour south and I turn and I'm still going 44 miles per hour, but now I'm going west, that's an acceleration because I changed direction. So it's any change in speed, going from 45 to 46 miles per hour, or from 46 to 45, that's deceleration, or if I change the direction that I'm going. The letters that you need to know, A is going to equal acceleration, VF is final or ending velocity, VI is initial or beginning velocity, so what the body started at, and T is going to be time. There is no fancy formula, or I'm sorry, a fancy triangle for this, so you will kind of have to be able to plug these into a formula. Positive acceleration means the object is going faster. You should highlight that. Also highlight that negative acceleration means the object is going slower, or it's also called deceleration. Formula: A, acceleration, equals VF, which is final velocity, minus VI, which is beginning velocity, all of that divided by T. You might also see it like it shows on the right. That little triangle means delta, and that actually means change in velocity. Exact same thing, taking final velocity minus initial velocity. You see parentheses around the subtraction. That means you need to do that first. Press equals, and then divide by time. The units for this are a little weird. You will take your top unit and add it to your bottom unit. So it could end up being miles per hour per second, because you have to have your velocity label, miles per hour, along with your time label, which is seconds. The bottom one says meters per second per second. So that means, hey, I'm going 2 meters per second faster every second I'm moving. So sometimes that's a little hard for kids to understand. Just know for acceleration, you basically need 3 parts to your label. Practice problem numero uno. Bill's car accelerates. You should see the word accelerate and know that it's going faster, from 25 kilometers per hour to 40 kilometers per hour in 4 seconds. So take a minute and think, what is his initial or beginning velocity? What did he start at? What velocity is he ending at? And then the time should be kind of obvious at 4 seconds. If we plug this into the formula, I always find it easier to put the VI in first. So his initial velocity was 25 kilometers per hour. Go to the other side and plug in your VF, which is 40 kilometers per hour. Then you're going to divide by your time of 4 seconds. 15 divided by 4 is going to give you 3.75. I took my label from top, which is kilometers per hour, and I also divided that by the label from the bottom, which is seconds. So the label is kilometers per hour per second. The next example problem is a little bit different. I don't know that I will make you do too many of these, especially not on the test, but it's worthwhile going through it. So you have a dog riding a motorcycle, which is always cool, starting at a velocity of 3.7 meters per second. If he accelerates at a rate of 0.2 meters per second squared for 5 seconds, what is his velocity after the 5 seconds? So now we're looking for the final velocity. So we're going to have to rearrange the formula just a little bit. As we pop it up here, you had time on bottom. So what we did is we took both sides times time to move it to the right side. And now you can fill in the letters. We don't know what VF is yet. You know his initial velocity is 3.7. You know his acceleration is 0.2. And the time is 5 seconds. If you simplify the right side, 0.2 times 5 gives you 1. Then you can go ahead and add 3.7 to 1. to give you a final velocity of 4.7 meters per second. And when I come back to the classroom, we'll go through another one of these and I'll show you how we got that initial formula if you didn't follow that. Buffy walks at a speed of 25 kilometers per hour. She slows to a speed, which you should know is deceleration, of 10 kilometers per hour in 2 seconds. So we want to know what her acceleration is. Final velocity minus initial velocity. So she's starting at 25 kilometers per hour. Put that on the right-hand side for VI. She is ending at a speed of 10 kilometers per hour. Put that on the left-hand side for VF. And divide by the time of 2. Taking a smaller number minus a bigger number is going to give you a negative number, and that's okay. Negative means deceleration, means she's slowing down. You take negative 15 kilometers per hour divided by 2 seconds, gives you negative 7.5 kilometers per hour per second. I'm going to post another set of practice problems. It's a mixture of the math from Monday, which was finding velocity and momentum, and some acceleration problems. I want you to divide your paper into the 3 columns, and I want you to try these. Like I said, once I can make it back to the classroom, we will be reviewing all of this. I will be going over all of the math with you, but I want you to try while while I'm not there, so that we have something to go off of. It's not okay for you guys to just sit there and not try. So try the math, work on the crossword, and we'll have one more lecture tomorrow. Hopefully I'm back in the classroom on Friday. Have a good day.